Well, welcome back. My name is Susale Mohana. Sorry. As I told you, there's an air conditioner here. It draws away the moisture, so I need to hydrate myself because my throat goes dry. Okay, of course, my own. I asked for this, you didn't, so I have to compensate for whatever I lose in terms of my voice. Okay, last time I showed you how to do e power x, how to apply formula for e power x. Today, I'll try and do some logarithmic functions. For example, remember the rule, whenever you're differentiating logarithmic functions, wherever possible, use the laws of logarithms before you differentiate. For example, let's see, find dy by dx when. I'll call this as question 2. Shall I remove e power x here? Okay. In the last one, I'll put e power x, ln x, and a power x. So I'm just doing ln x now. When part A, y equal to ln x squared plus 2x minus 3 the whole cube. Right, let's do it the long way. So y equal to ln u cube, u equal to x squared, ln u is equal to v cube, and v equal to x squared plus 2x minus 3. And then you do dy by du, then you do du by dx, then you do du by dv, dv by dx, use chain rule. Or how do you use it in calculator? Put x as 1, you first find this, then cube it, then take ln. So reverse, first differentiate ln, then differentiate the cube, then differentiate what is inside. Quite complicated, isn't it? But as I made a statement in the beginning, whenever you have a question, where possible, use laws of logarithm. I'll show you how life becomes easy. First and foremost, remember, log of x power n is n log x. So y equal to, again, I tend to forget starting my watch. Always. That's about 3 minutes. Okay. Y equal to 3 ln x squared plus 2x minus 3. At least now I can say y is equal to 3 ln u equal to x squared plus 2x minus 3. I can differentiate and multiply. But still I have to simplify. Whereas, can you factorize this? This is 3 ln x plus 3 times x minus 1. So 3 times ln x plus 3 plus ln x minus 1. Now what do you notice? No product rule, no function of a function, no chain rule, differentiate directly. So what's dy by dx? 3 is a constant, ln gives you 1 over x plus 3, that ln gives you 1 over x minus 1. Why is it 1? Because if this were to be 2, then I have to multiply this by 2. If this were to be half, I would have multiplied that by half. But there are no numbers before x, so there is nothing else you need to do. Now I can take LCM 3 times. The LCM is x plus 3 times x minus 1. It's x minus 1 plus x plus 3. So 3 times, it's 2x plus 2. 2x plus 2 over x plus 3 times x minus 1. At A level, they expect you to give the answer like that. Most probably in the exam, if this question comes, they will say, write simplifying your answer. And when we say simplifying, they expect you to arrive at that answer. Good? Okay. Let's take another example, part B. I'm not going to do anything about a power x. You will find 2 power minus x, 3 power x there. Alright? I'm worked out questions here, so I'm keeping them. Let me see. X squared. Yeah. Y is equal to x squared ln x. The moment you have a product, use a product. So dy by dx equal to, look, you must get used to applying the, otherwise call u equal to x squared, v equal to ln x, find du by dx, find dv by dx, blah blah blah. So u is x squared, dv by dx is 1 over x, plus v is ln x, du by dx is 2x. So I can remove x as a common factor, 1 plus 2 ln x. If you want to, you can write as 1 plus ln x squared, or if you sometimes, if the examiner wants to test you, they might say, show that dy by dx equal to x ln ex squared. Let me put it, show dy by dx equal to x ln ex squared. Okay. So this is x. 1 can be written as ln e plus ln x squared. So it becomes x ln e x squared, big D. That's how you show it. Okay. Now this is this part C. I want you to remember this next few results. Y is equal to ln sec x. You're asked to find dy by dx. Yeah? Let's differentiate. I must use chain rule or onion rule. I use onion, you use chain rule. How do you solve this? Put, suppose what 30 degree at pi over 4. Find sec pi over 4. Then do ln. So the last thing you do is ln. So the first thing you differentiate is ln. Ln x gives you 1 over x. Ln sec x gives you 1 over sec x. And sec x gives you sec x tan x. So which is tan x. Now I want you to keep this in mind, because when you do integration, we use this formula, or it's in the formula book. When you integrate tan x, you get ln sec x. Okay? Part D, y equal to ln sin x. What's dy by dx? Dy by dx is log gives you 1 over and sine gives you cos. The answer is cot x. Again, this is a relation you need to remember, because when you want to integrate cos or cot x later, the answer is ln sin x. Yeah. And life becomes more difficult. Let's look at part E. Y equal to ln sec x plus tan x. Show dy by dx equals sec x. No problem. We use, if you want to call u and v and w, but I'll do it directly. When you want to find the value of y when x is pi over 4 or pi over 3, first find the value of that, then take ln. So for differentiation, onion rule, start from the outside. So the outer layer is ln. ln gives you 1 over sec x plus tan x. That takes care of the ln. I need to differentiate what is inside. Sec x gives you sec x tan x. plus tan x gives you sec squared x. What common factor can I remove in the numerator? Sec x. What am I left with? Sec x plus tan x. In the denominator, what am I left with? Sec x plus tan x. Pop, pop. The answer is sec x. This is another result I want you to remember, because when you integrate sec x, you will get ln sec x plus tan x. Alright? I've got two more examples to do on logs before I proceed further. So I will take them up as separate examples and do them. I'm just trying to show you how to apply onion rule, quotient rule, product rule, whatever rule you think of, to logarithmic functions. And then I'll just take one interesting but challenging question, which I hope does not come in the exam, but can definitely come. Let me just do this question before I go there. Okay, question 2. It could be 3, I'm not bothered. If y is equal to ln x plus root x squared minus 1, show that dy by dx equal to 1 over root x squared minus 1. Huh? Should I make it complicated or bringing in an a? No. Okay, let's leave it at that. Alright? Before I proceed, I'll write this as ln x plus x squared minus 1 power half. Now, ladies and gentlemen, for heaven's sake, don't write this as ln x plus ln. Log of a plus b is log a plus log b, or log of x times that is a new branch of maths, which in my, now I'm 70, I started learning calculus at the age of 16. So in my life of 1672, my 56 years, I've never come across that. Yeah? So be careful. So now, what is dy by dx? Again, using onion rule, log of anything gives you 1 over the same thing times, I need to differentiate that, which is the same as differentiating that. X gives you 1, x squared power, look, this is something power half. So anything power half gives you half times same thing power minus half. That takes care of the power half. And then x squared minus 1 gives you 2x. So this is 1 over x plus root x squared minus 1 times 1, look, the 2 and the 2 cancels, plus x over root x squared minus 1. So this is 1 over x plus root x squared minus 1 multiplied by, take root x squared minus 1 as LCM, I get root x squared minus 1 plus x. That goes with that. What am I left with? 1 over root x squared minus 1. People doing further maths, that's the derivative of cosh inverse x or r cosh x. But it can, then some of you say, sir, but we don't do further maths. Why are you doing this for us? I did use further maths. I took a logarithmic function, showed you how to differentiate. That's got nothing to do with further maths. Okay. Now I want to take one challenging question. Very interesting, but a big question. find what is this question? Find sorry, I just have to look at the question because I made it up. 11 pi by 4. Not by 4, less than, more than 2 pi, but less than 3 pi. Find the coordinates of the stationary points. I told you on the curve y equal to e power minus x cos x. Yeah, that lie in the range 0 less than or equal to x less than 4 pi. Yeah. Hence, deduce that the stationary points, the stationary values are the successive terms of a geometric series. State the common ratio. State the common ratio of this series. Now I'm going to rub this off because I need the whole board to. So in other words, you are given the graph of curve y equal to e power minus x cos x. You have to find the coordinates of stationary points in the range 0 to 4 pi. When you find, remember x gives the stationary value, y is the stationary value. So you find the various values of y in the range 0 to 4 pi. Okay? I'm sorry, for the values of x in the range 0 to 4 pi. Then looking at that pattern, deduce that all the values of y are terms of a geometric sequence and state the common ratio. I can't do sum to infinity because I have to then give a starting point. I don't want to extend the question beyond. Is the question clear? So I repeat, first we need to find stationary points, then find the, consider the values of y and show that the terms of a geometric sequence. The range is 0 to 4 pi, not 0 to 2 pi. I could have made it minus 4 pi to 4 pi. I don't want to. So I'm going to rub this off, just leaving that there so that I can use that to show the answer. Is the question clear? So therefore, I think I just have enough time. What's dy by dx? u is e power minus x times minus sin x plus v is cos x times e power minus x gives you e power minus x times minus 1. Equate it to 0. So I get minus e power minus x times cos x plus sin x equal to 0. You could say sin x plus cos x, but it's easier to look at because I want cos x there. What is this? Is using the R formula. Cos x plus sin x is equal to R cos x minus alpha. Remember we did in trigonometry. So that is R is equal to square root of, remember your A is 1, B is 1. R is root 2, tan alpha is B over A, gives you alpha equal to pi over 4. So dy by dx equal to minus root 2 e power minus x cos x minus pi over 4. You equate it to 0. So your PV is pi over 2. Now do you understand why I did trigonometry, R formula, cosine formula, and then how to find general solutions, all that before I started differentiation. In one question, we're doing the whole of trigonometry. Very good. Of course, you could equate it to 0 and get, perhaps, but I need that root 2, otherwise you won't get it. Why? No, not necessarily. I could have done it easily. Doesn't matter. Let's do it this way. Because what if we do something else? Okay. So therefore, x minus pi over 4 equal to 2 pi n, 2 pi n plus pi over 4 or 2 pi n minus pi over 4. So x equal to 2 pi n plus pi over 2, then 2 pi n. Correct? Yeah. Is that correct? Then alpha is 1, alpha is pi over 4. Yeah, it's 0. So, okay. So put n as 0, x equal to pi over 2 and 0. Put n equal to 1, x equal to 2 pi plus pi over 2. 3 pi by 2 and then 2 pi. Put x equal to 2. No. There is something wrong somewhere. R cos x minus alpha, R is root 2, alpha is pi over 4, PV is pi over 2. Oops. This was pi over 2. That was pi over 2. I was wondering, where am I going wrong? Okay. That's 3 pi by 4 and that is minus pi over 4. Hey, one silly error. You know what? I wrote the PV as pi over 2. There I wrote it as pi over 4. Very clever man. So therefore, n equal to 0, x equal to 3 pi by 4. That's out. Put n equal to 1, x equal to 4 to the 8 plus 3, 11 pi by 4, 4 to the 8 minus 1, 7 pi by 4. N equal to 2, x equal to 2 to the 4, 16 plus 3, 19 pi by 4, is it? 4 to the 8 plus 3, 11, no, I'm putting 2 to the 4. 4 to the 16 plus 3, 19 pi by 4, 16 minus 1, 15 pi by 4. This is more than 4 pi. Isn't it? 4 4 is 16. So I have answers as 3 pi by 4, 7 pi by 4, 11 pi by 4, and 15 pi by 4. X equal to, right? So let's call this as x1. Okay, x1 equal to 3 pi by 4. What is y1? Y1 is e power minus 3 pi by 4 times minus 1 over root 2 cos of 3 pi by 4. Okay, x2 equal to 7 pi by 4. So y2 will be e power minus 7 pi by 4 times 1 over root 2. x3 is 11 pi by 4. So y3 is e power minus 11 pi by 4 times minus 1 over root 2. x4 is 15 pi by 4. So therefore y4 is e power minus 15 pi by 4 times minus 1 over root 2. Now, how do you get this from that? Multiply by e power minus pi. From this to that, e power minus pi. Now 7 pi by 4 minus 3 pi by 4 is minus 4 pi by 4. Minus 4 pi by 4 is minus 1. So e power minus pi. When you divide this by this, e power minus pi. When you divide that by that, e power minus pi. So it's a geometry. You show this, please. Y2 over Y1 equals Y3 over Y2 equals Y4 over Y3 equal to e power minus pi. So it's a geometric series. All the stationary values or successive terms of a geometric series with common ratio e power minus pi. That's a beautiful question. But remember, in one question, differentiation, exponential functions, product rule, onion rule, then trigonometric equations, and then finding, solving solutions, then doing geometric series of division using indices. How many topics are covered in one question? And that's a typical high standard A-level question that can come up. And if I were to be setting a paper, it would come up, but you're lucky I'm not setting the paper, so you're very safe. So that's a short course on exponential and logarithmic functions. I didn't bother much about a power x because it's difficult to make up questions. I can sit and do it, but to make up questions which are straightforward answers, which give straightforward answers for a power x. So I didn't do that. So you can get questions on that from the textbook. So I've shown you this. In the next lesson, I will do implicit differentiation. And then we'll go to related rates and hopefully finish. And then I want to talk to you about something about increasing and decreasing functions. And I also want to talk to you about point of inflection, how to determine points of inflection. And then we will start with the next headache, integration. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.